Friends, in this lecture, I will talk about pseudo forces or the fictitious forces that come into picture when we try to describe the motion of an object in a non-inertial frame. So, when the motion of an object is being observed by an observer which is sitting in a non-inertial frame, then while applying the Newton's second law to describe that motion, we have to consider some fictitious forces, and that these fictitious forces are not actually the result of a physical interaction. These fictitious forces are actually occurring there because of the reference frame is itself accelerating. So the origin of these pseudo forces or the fictitious forces is actually because of the acceleration of the frame itself. Now, if we try to describe the same motion from an inertial frame or from a non-accelerating frame, then we do not need these forces at all. So these forces will be needed only if the motion is being observed from a non-inertial frame. Now, this is the general force equation for an object being observed from a rotating reference frame. So as we have already said that the frame of reference which is having linear acceleration, or when the frame is rotating, then that frame will be an example of a non-inertial frame. Now here I have shown the force equation for a rotating reference frame. Here this F dash is actually the observed force on the object in the non-inertial frame under consideration, whereas this F represents the actual force or the true force which is acting on the object. Mass of the body or of the object is represented by m, and omega is the angular velocity of the rotation of the frame, and this v prime or v dash is actually representing the velocity of the object with respect to the rotating reference frame, and this r is the distance of the object from the axis of rotation. This alpha is actually d omega over dt, which is representing the rate of rotation of the reference frame. So here we are considering that the frame is not under uniform rotation. The angular speed of the rotation of the frame is varying with time. So in this picture, in this special case, three different types of pseudo forces will have to be considered, or these forces will affect the motion of the object under consideration. The first pseudo force or the first fictitious force is the Coriolis force, which depends on the velocity v dash of the object seen in the rotating frame, and this Coriolis force is actually this term given by this term. So minus of 2m omega cross v dash represents the Coriolis force. So you can see that this v dash is appearing here. So if the object is at rest with respect to the rotating frame, then the Coriolis force acting on the body will be 0 because of v dash being 0. So for this Coriolis force to be non-zero, the object must be in relative motion with respect to the non-inertial or the rotating reference frame. Then the second term over here is the centrifugal term, which is representing the centrifugal pseudo force acting on the object. This depends upon the value r. So when the frame is rotating, then what is the distance of the object from the axis of rotation will decide the value of the centrifugal force acting on the object under consideration. Then the third term is actually this one, that is m alpha cross r, and where alpha is d omega over dt. This represents the another type of pseudo force, that is the Euler force, and this basically depends upon this factor alpha. So Euler force will be non-zero only if alpha is non-zero, that is d omega over dt is non-zero. So this means that if the frame is non-uniformly rotating, only then the Euler force will be non-zero. Now for a rotating reference frame which is uniformly rotating, this alpha will become 0 and hence the Euler force on the object will become 0. So Euler force will be non-zero only if the frame is under non-uniform rotation. This fact has to be keep in mind. So here I have shown the inertial frame in which the object is making straight line motion. Then when this straight line motion is observed by an observer which is outside of this frame, this rotating reference frame, so observer is not rotating, so this motion is being observed from an inertial frame. So when this motion is observed from an inertial frame, then the straight line motion will appear to be a straight line. There will be no change in the nature of the motion. So in this case, no extra force is needed, that is no pseudo force is involved in the discussion of the motion of the object. While in the second case, the observer is himself or herself sitting over the rotating disc and the object being observed is also on the disc. So in this case, the observer is lying inside the rotating frame which is a non-inertial frame. So in this case, the straight line motion of the object will appear to be curved on the curved path, and this is the result of the presence of fictitious forces which has to be considered in this description of the motion of the object. So actually the physical motion is identical in both cases, but because of the viewpoint of the observer is changing, as the observer in the two cases are observing the object in the different perspective, so the motion seems to be different. Now let us consider the first type of pseudo force. So this is basically the centrifugal force. So this centrifugal force is actually the outward push felt inside a rotating frame. So here this object is lying over this rotating frame, and this is the axis of rotation, and the angular velocity of rotation is given by omega, and the rotation is in this direction, that is the clockwise rotation is here, and the object is at a distance r perpendicular from the axis of rotation. Then the centrifugal force will be directed outwards in this direction, and this appear to be acting on the object just because of the rotation of this observer. This observer is itself on the rotating disc. So since the observer is rotating, it is having some acceleration, so this object will feel an outward push in this direction, and this push is because of the presence of this centrifugal force. So object actually is at rest on this platform, but still it feels an outward pull in this direction. Now for this centrifugal force, you can see that from that force equation shown on the first slide, this Coriolis force will be present whenever the frame is rotating. That means if omega is not 0, then Coriolis this centrifugal force will be present, and in this case there is no requirement of relative motion between the object and the reference frame. So even if the object is at rest, the centrifugal force will be present on the object. Now here this FCF is given by the expression minus m omega cross r. So the magnitude is this much, m omega square r perpendicular, and the direction will be radially outwards. So in this case, from that force equation we can see that Coriolis force is equal to 0 since v dash equal to 0. The object is at rest, remember, and Euler force will be 0 because the rotation considered over here is the uniform rotation. So both these forces are 0 in this case, and only the centrifugal force is present, and the magnitude of centrifugal force is this much, m omega square r perpendicular, and the direction is radially outwards. Now key properties for this centrifugal force are actually, this centrifugal force depends upon the distance of the object from the axis of rotation, and it is exactly 0 on the axis. So if the object is placed here, then it will become 0, because in that case r perpendicular will become 0. And the second property is that it depends upon the values of omega square and r perpendicular. So if these values increase, then the value of centrifugal force will also increase. Now some examples, common examples in daily life in which centrifugal force is present is basically the felt this force is felt by a passenger swung outward in a sharp turn in the laundry pressed to the wall of a spin dryer, and also by riders on a merry-go-round. So centrifugal force can be seen in these real world problems. Now the second pseudo force is very important force, that is the Coriolis force. This Coriolis force is actually a sideways deflection of motion within a rotating frame, and the very important thing about this force is that this force will be present only when the object is in relative motion with respect to the rotating reference frame, and secondly the rotating frame, the frame should be rotating, actually it should not be under the frame should be rotating, only then this force will be present. So two things are required: the object should be in relative motion with respect to the frame, and the frame should be rotating, then Coriolis force will be non-zero. Now in this case centrifugal force may or may not be 0. Centrifugal force will be 0 if the distance of the object from the axis of rotation is 0, and centrifugal force will not be 0 if the distance of the object from the axis of rotation is non-zero. So centrifugal force may or may not be 0 in this case, but for this Coriolis force to be 0, we can see that if omega dash is 0, then Coriolis force will become 0. If the frame is non-rotating, that is omega is 0, then also the Coriolis force on the object will become 0. Now its direction is given by this omega cross v dash. Omega and v dash are two vectors, so the direction of Coriolis force will be perpendicular to the plane of the plane formed by omega and v dash, that is it is perpendicular to the directions of both omega and v dash. Now key properties of this Coriolis force are actually, this Coriolis force is perpendicular to this velocity, so it will not make any change in the kinetic energy of the object, and it will only change the direction, it is not changing the speed of the object. So there will be no work done by this Coriolis force, so work done by this Coriolis force is always 0. Secondly, it reverses direction whenever omega or v dash reverses. So in this expression you can see that if we place minus v dash in place of v dash, or if we place minus omega in place of omega, then there will be a change in the sign of this Coriolis force, and a change in the sign of the Coriolis force means a change in the direction of the Coriolis force. Now some real world examples in which Coriolis force is felt are the actually some natural phenomena, that is the shapes, the spiral of hurricanes. So the spiral of hurricanes are actually affected by the presence of Coriolis forces. Second important phenomena in which Coriolis force is observed is the curbing of ocean currents. Ocean currents get curved because of the existence of Coriolis force. And for the now the third important force, third type of pseudo force is actually the Euler force. So this Euler force is present only for the non-rotating, only for the non-uniformly rotating reference frame. So in this case, the object is present inside a non-uniformly rotating reference frame. So this alpha is equal to d omega over dt, and in this case it must not be 0. So you can see that d omega will be in the direction of omega, or that is alpha will be in the direction of omega. So alpha is in this direction along the direction of axis of rotation, and r perpendicular is the distance of the object from the axis of rotation. So in this case, the Euler force is given by this expression, and magnitude is given by m alpha r perpendicular. So it will be tangential. So this is the tangential force. Euler force is the tangential force. So for alpha along the rotation axis, the force acts tangentially, that is at right angles to r. R is here, so this tangential force will be along this direction. Now important properties of this Euler force are actually this will be absent, Euler force will be absent, or it will become 0 when the frame of reference is in uniform rotation. Okay, so if omega is constant, then alpha will become 0, and in that case Euler force will be absent, or it will be 0. Now this Euler force can act even on an object which is momentarily at rest relative to the rotating frame. So there is no condition of relative motion between the object and the frame. The object may be at rest, even then this Euler force may be present in the description. Now this real life examples of Euler force are actually the backward tug. When a merry-go-round speeds up, its rotation speed is increased, then the person standing on this merry-go-round will feel backward tug. And if the merry-go-round slows down, that is some brakes are applied, then the person standing over the merry-go-round will feel forward lurch. So these are the real life examples in which the Euler's force is the presence of Euler's force is felt. Now in this slide I have shown the effect of Coriolis force in the northern hemisphere as well as in the southern hemisphere. So when we are considering the motion in the northern hemisphere, in this northern hemisphere, then because of the Earth's now Earth is rotating about its axis from in this direction. Okay, so the object under in the motion will be deflected to right of its actual direction of motion. So the actual motion direction is along this direction, then it will be deflected right in the northern hemisphere, and in the southern hemisphere, when the direction of motion is along this, then it will be deflected to the left. So this is purely the result of the Coriolis force being present in this case, and this basically is the earth is actually rotating, so it is a rotating frame. So because of this earth's rotation, the object's motion is seen deflected towards right in the northern hemisphere and towards left in the southern hemisphere. So important note about this effect of Coriolis force is that this left-right reversal is specific to the Coriolis force. This left-right reversal doesn't occur for centrifugal and Euler forces, because these forces are frame dependent. These do not depend upon the northern or southern hemisphere. Now here is a quick comparison between the three types of pseudo forces, that is the three types of fictitious forces. you can see that all three forces have the same origin, but these three are actually present under different conditions. Origin is same, and that origin is basically the rotation of the frame itself. So first type of force, that is the centrifugal force, is given by this relation. Magnitude of centrifugal force is given by this. So trigger is that omega is not equal to 0. So if omega is not equal to 0, only then this centrifugal force will be present. No other requirement is here for the centrifugal force to exist. So reference frame should be rotating. That is sufficient for centrifugal force to be to come into picture. Now its direction is radially outwards, and it depends upon the values of omega square, and distance are perpendicular, which is the distance of the object from the axis of rotation. And its real life examples are a turning car, a spin dryer, for the centrifugal force to show its effects. The second type of force, that is the Coriolis force, is very important force, and it is given by this expression. So the trigger for this is we require two conditions. First condition is that omega should not be 0, that is the frame should be rotating. And the second condition is that the object should not be at rest relative to the reference frame. So in the first case, the object is at rest or may be at rest, but in this case specifically the object should not be at rest. It should be moving with respect to the rotating frame of reference. Only then, if both these conditions are satisfied, only then the object will feel the effect of Coriolis force. So, and its direction is perpendicular to both the angular velocity and the speed of the object relative to the reference frame. Its value depends upon the values of omega and v dash, and its real life examples in which the effect of Coriolis force is present are actually the hurricanes and the ocean currents. The third important pseudo force is the Euler force, given by this mathematical expression, and for it to present is actually the condition or the requirement that the frame of reference should be rotating non-uniformly. That is, the angular speed of the frame should not be constant, and the direction of this Euler force is actually the tangential. It depends upon the values of alpha, that is the rotation speed of the frame, and the perpendicular distance of the object from the axis of rotation. And this Euler force is observed in case of merry-go-round speeding up or slowing down. So all three types of pseudo forces vanish for an inertial observer. So if the observer is stationed, or if the observer is sitting inside an inertial frame, then all these three type of pseudo forces will be absent. None of them will be present for an observer sitting in an inertial frame. So these forces exist only when the observer is observing the motion of an object from a non-inertial frame, from a rotating frame, and possibly this rotating frame is non-uniformly rotating, then all three type of forces are present. So thank you.